Major compaction, minor compaction ఒకసారి చెప్పండి సార్.
Sorry guys. So last week we were talking about major compaction and minor compaction. So I've shown you what is this major compaction and what is this minor compaction. Okay, so let me show you once again here. Okay, when I say normally what will happen, okay, whenever you insert any data into HBase, initially the data will be stored in HBase memstore. Okay, once okay it reaches that 128 MB size, then automatically that data will be flushed into HDFS. Okay, so now okay, let us take it like this. Okay, so every 128 MB of data you insert, okay, the data will be flushed to HDFS. It means okay, every 128 MB data HBase data will be stored like one file into HDFS. Okay, suppose if you store 1 TB data, then okay, you will have 8192 files. Okay, HBase files. Okay, if you store 1 TB data, that 1 TB data will go and sit like a 8192 small files, sub files. Okay, but okay, so the more small files you have, it's a problem on name node actually. So because okay, every file, okay, name node has to maintain metadata for each and every file. That is the reason, okay, it's a problem. Okay, so we have a concept called compaction. What is compaction? Compaction means okay, merging small files into a big file. Okay, automatically is called as compaction process. Okay, so there are two types of compactions here. Okay, one is minor compaction and other one is major compaction. Okay, so when it comes to minor compaction, so what it is doing, okay, so okay, yeah, this is what okay, we need to check actually. So this is the place where I created the table. I inserted some data. Okay, I flushed this data manually into HDFS. So it created one H file for me. Every flush will create one separate file for me. Okay, so after that I inserted two more entries. Okay, then I flushed again. Okay, these two entries have gone in a separate H file. Okay, now if I say scan student, okay, so it is showing okay, so both the data from both the files. Okay, now okay, again okay, I inserted one more data. Okay, one more field. Okay, so again okay, I did flush, then it has created one more file for me, H file 3. Okay, so first H file is having this much data, and second H file is having this much data, and third H file is having this much data. Okay, so now if you see, all these are small files. Okay, so if you have more, it is a problem for HBase. Okay, for name node, if you have more number of small files. Okay, that is the reason what we are doing. Okay, we are doing some kind of a minor compaction. Okay, so normally minor compaction will be taken care by HBase automatically. So here, okay, what I'm doing, okay, I'm trying to alter the table, okay, by changing the number of versions. Okay, when you alter the table, automatically what happened, okay, it combined all these small H files into a big H file. Okay, H file 4. Okay, so when it created H file 4, it deleted H file 1, 2, 3. Okay, there were no H file 1, 2, 3. We have only H file 4. Okay, after that what I did, okay, so again, okay, I inserted one more field. Okay, so now I have H file 4 and H file 5, okay, in HDFS. Okay, now when I do major compaction, okay, so if you see here, okay, I want to maintain only last three values. Okay, but here for John, so I have Johnson, John. Okay, 4 entries are there, 4 versions are there, but okay, I'm asking to maintain only 3 versions. Okay, when you do major compaction, okay, it will merge the data and okay, find okay, if there are any excess versions. If yes, okay, it will delete that. Okay, so the simple version. Okay, so here, okay, so for every flush operation, HBase will create a new file in HBase TLS path. What is minor compaction? Minor compaction is the process to merge multiple small files into one big H file without deleting the expired cells or data. What do you mean of expired cell? Excess data. Understand? Excess data means, suppose, okay, I want to maintain, okay, 3 versions, last 3 versions. Okay. Now, okay, John is the excess one now. Okay. So latest 3 means Johnson, Johns. Okay. John is the excess version. So deleting the excess. Okay. Without deleting the excess data. Okay. But when it comes to major compaction, it's a process to merge multiple small files into big H file by deleting the expired or excess cells. Okay. After doing major compaction, your expired cells, okay, expired or excess, okay, excess data will be permanently removed from HBase table and cannot be recovered. Understood? Suppose, okay, if during major compaction, if any data is corrupted, okay, that cannot be recovered. That's what HBase is saying here. Understand? Okay. So this is what, okay, we have seen practically also. Okay, but now let us come back to the theory part. Okay, try to understand, okay, what is HBase architecture, how it works, okay, internally. We have seen practically, but okay, theoretically also, okay, we will see now. Okay. And okay, if you see the HBase architecture, you will have one or more H masters, and okay, you will have multiple region servers. Okay. So these are multiple region servers. Okay, you can have, okay, any number of region servers. Okay, but if you see our example, what we have done, okay, so we had total 100 data nodes, okay, 97 data nodes. Out of 97 data nodes, okay, we made only 50 region servers as, okay, 50 nodes, okay, as region servers. Okay, it means, okay, on these machines, 50 machines, okay, so region servers are running. Understood? Understood? Are any questions? It means on this machine, okay, we have data node is running, name node manager service is running, Impala service is running, HBase region servers, H region server service also running. Okay, so this is what is happening. Okay, so how many Impala nodes we want or how many H region servers we want, okay, that is purely based on your requirement. Clear? Okay, see, we have 2000 node cluster. 2000 nodes cluster. Okay, in this around, okay, we have 1900, okay, 30 data nodes. Okay, 1930 data nodes. Okay, and okay, here out of this one, we have only around, okay, 90 H region servers. Understood? H region servers. What does it mean? For us, okay, only 90 nodes is sufficient. 90 nodes are sufficient for HBase. We don't require, okay, all 1930 data nodes, okay, as data nodes, as H region servers. Understood? It is purely depends on your requirement. How many H region servers they will start. Clear? Clear? Are any questions? Okay. So, and you can have multiple H region servers. Okay. So now, so you have H master and you have H region servers. Okay. H master and region servers. Okay. H master and H region servers. H region servers are the one who will hold the regions. Okay. So one H region server may have multiple regions. Okay. See here, okay, we have R3, R4, R5, R6, R7, R8. Okay. So it means, okay, one region server is having, okay, 2 regions here. 2 regions. Understand? One region server is having 2 regions. Are you clear? Are any questions? Okay. So like this, okay. So here, okay, here you see, okay, one region server may contain, okay, multiple regions from multiple tables also.
Is
okay?
it based on
based on
size of region?
Okay. Normally, okay. So initially, when you create a table, okay. So what are the default thumb rules here, guys? Normally, okay. Okay, you created a table. Create a table. Okay. You don't tell how many regions you want. How many regions it will create initially. If you tell how many splits, okay. Okay. So suppose okay. So now, okay. So how many? If you tell. Understand? If you don't mention number of splits or regions, okay, then okay, HBase will create by default one region. Correct or not?
Yes.
Okay. But if you tell okay, I want 5 regions. Okay. So if you say that okay, 100 comma 200 comma splits, if you tell 100 comma 200 comma 300 comma 400 comma like that, if you tell HBase will take those many regions. Okay. So by default, okay, when a region is created, okay, it is 0 size. Okay. But okay, whenever if you keep on inserting data, the region will be keep on growing. Initially, okay, let's say this is the table, employee table. Employee table, it has only one region. Initially, it has only one region. Okay. This is the region. There is no data inside this one. Correct. Okay. This is the region. Okay. There is no data inside this one. Okay. Okay. So initially, you can say that okay, the small region size can be okay. Let's say 10 KB. Okay. The more and more data you insert, what will happen? This will be keep on growing, right? Yes or no? So the more and more data you insert, okay, it will be keep on growing. Okay. But what is the maximum size it can grow?
GB.
10 GB. It can go up to 10 GB. Okay. Once it reaches 10 GB, so then okay, automatically HBase will get one more region for the new data. Understood? Again, okay, this is also okay. When it is created, okay, initially this is of 10 KB again, 10 KB. Okay, but this can grow maximum of the more and more data insert. Okay, so it will go up to 10 GB. Okay, after that, okay, you still have some more data. Then automatically create third region. Okay, initially it will be 10 KB size. It can go up to okay 10 GB. Like this, okay, the more and more data you insert, okay, more and more regions will be automatically created, and more and more regions, okay, created and stored data will be stored in those regions. Got it? Got it or not? I guess three days gap, okay, is creating problem now.
Got it.
Yeah. Okay, so it means okay, one region server may contain one or more regions, okay, from the same table or from different table also. Okay, so I would say H region server is equal to set of regions. Okay, from same or different tables. Set of regions from same or different tables. Okay, so now you have okay H. Okay, inside H region, what you have? Let's see what is there inside H region. Okay, so inside H region we have something called H log. Okay, and you have something called store. Okay, what is store, guys? Okay, normally, okay, you see this if you this as a region. Okay, so this is an H region server 2. Okay, so this is there inside H region server 2. Okay, okay, think that there are two. Okay, R11 and R12, two regions. Okay, we have. Okay, this is R11 region. This is R12 region. Okay, under each region, okay, we have okay 4 column families. Correct? Correct or not? Each column family is called as one store. Okay, one store. Understood, sir? each column family is called as one store. Are you clear? Are any questions? So I will say that okay, this H region server is having, okay. So H region server 2 is having, okay, 2 regions, okay. So R11 region is having, okay, 4 stores. 4 stores. Understood? Each column family will go like one store. Okay. Inside store, you have something called mem store. Okay. Inside each store, you have something called mem store. What is this mem store is? The name itself is okay, mem, okay, memory store. Okay. So it means okay, whenever okay, you insert any data, until it become 128 MB, the data will be inside memory of the region server. Inside the memory of the region server. Okay. So once your data is okay, data is created like data is reached 128 MB. So it will convert that 128 MB data into a store file. Okay. Store file. Okay. Then the store file will be flushed to HDFS using DFS client. Understood? Okay. So end of the day, so whatever data you insert into region, first that will be recorded in the HLog. Okay. So then it will be stored into the respective store. Okay. And okay, there in that respective store, okay, you have something called mem store. Okay. So that your data will be stored in mem store. Okay. So till when it will be there in the mem store? Till it reach 128 MB. Okay. When it reach 128 MB, automatically it will be converted like a store file. Okay. And that will be flushed into HDFS. Okay. Using DFS client. Understand? Are any questions? So finally, your data will be on HDFS only in the form of blocks. Okay. So this is HBase architecture. So let us try to understand HBase read and write operations actually. Okay. So normally when you create a table, what will happen? So here is the client. Okay. So you will log into HBase prompt. Okay. And you will run a command, create table command. Okay. So here there is something called Zookeeper. What is this Zookeeper here? So Zookeeper is a mandatory service in HMaster. Correct. Okay. Where and all we are using Zookeeper guys so far? And all we are using Zookeeper. Are we using an SDFS?
Yes, sir.
Okay. In Yarn, are we using? In Yarn, are we using?
Resource manager.
Resource manager high availability.
Yes,
Right?
manager.
Resource manager high availability we are using. Okay. Apart from this, are you using it for any other purpose? If you want to store application state store, common copy of application state store okay, across 3 Zookeepers. Or if you want to maintain an application state store in memory, then okay. So application state store. Understood? Okay. So this is okay. Optional. If people decide to go with HDFS, then okay, they can store in HDFS. If they want to store in RAM, okay, they choose Zookeeper here. Okay. And okay, are we using Zookeeper in Scoop? Huh? Are we using Zookeeper in Scoop? No. Okay. Scoop. No. Okay. Then Hive. Yes, you are using. Okay. So to understand, okay. So in Hive, okay, you are using so HS2 LB. Okay. What is this HS2 LB load balancer? To understand okay, how many load balancers, how many Hive server tools we have, which Hive server tool is free, that information will be maintained here. Okay. And second thing, okay, where okay, so in table logs, Hive table logs. Okay? To maintain Hive table logs, we are using Zookeeper. It means okay, Zookeeper can be used in Hive also. Okay, but when it comes to HBase, okay, it is mandatory. Okay, so here, okay, HMaster availability. Okay, so if you want to, if you have two H masters, let us take this scenario. How many H masters I created? I have only one H master. I can add one more H master also. Okay, when you enable two H masters, then okay, then this will decide okay, who should be active H master and who should be standby H master. Understood? Okay, clear or not? And here, okay, common copy of HBase metadata. Okay, so a copy of HBase metadata also stored in Zookeeper here. Okay, so in most of the places, okay, we are using Zookeeper. Okay, maybe okay, one tool okay, is doing one work, okay, other tool it is doing other work, but okay, end of the day it is happening. So no, it is. I mean, Zookeeper being used in multiple services. Okay. So when okay, somebody send a request actually. Okay, so if somebody try to create a table or if they want to insert some data, so here client okay, the request okay, will never directly hit HMaster. The request will be given to Zookeeper. Now Zookeeper will see which HMaster is active and forward that request to that HMaster. So he is a coordinator between okay, your client and HMaster. Understood? So okay, Zookeeper is a coordinator between your client and HMaster. Okay, so now, okay, if there is a table creation request, what it will do, HMaster will accept the request and okay, it will update in the metadata and finally it will see which region service is having less regions and create a region inside that. And okay, creating a region means okay, when you see on HDFS creating a table directory inside that, okay, creating a region directory inside that, okay, creating a subdirectory for each and every column family. Okay, so this is what it does okay, when you create a table. When you insert a table, when you insert some data into table, what will happen? Client connects to Zookeeper. Zookeeper will forward the request to HMaster. Now HMaster will check the metadata and tell that okay, so you are trying to insert a student ID 201. So 201 should go to third region or a second region. Okay, so you send it to second region which is running on H region server 2. Okay, so where to store the data? Okay, so the indexing, okay, or partitioning, all these things will be controlled by HMaster. So HMaster is a person who will just guide the client. Understand? Okay, so HMaster is not keeping the data anywhere or cannot reading the data anywhere. Okay, HMaster is the one who is guiding the data while inserting the data, guiding the client while inserting the data and while reading the data also. Understood? Okay, so here okay, so based on the HMaster's help, okay, so client will understand okay, my okay, whatever the data I'm inserting, that data should go to this region which is running on this region server. Okay, so automatically the client will hand over the data to this region server and ask okay, this region server to store it in this region. Okay, so each region server is the one who will store the data into this region now. Understood? Okay, so finally HCG servers are the ones who will be maintaining the regions and okay, the regions, okay, so whatever the data we are inserting into the regions, okay, they will be tracked continuously. Okay, whenever there is 128 MB, it will be automatically flushed to HDFS in the form of a H file. Understood? Okay, even while reading also, client submit a request, Zookeeper will accept the request and send it to HMaster. Now HMaster will see okay, which table, okay, what and which region okay, the data is available, and okay, it will confirm the client saying that okay, so you are searching for this entry, so this is available in so and so region server and so and so region, so go and read it. So now client will connect to that particular region server and ask to read the data from particular region, so that okay, the data will be read. Got it? So this is how the read and write operations will happen on HBase. Okay, so everything will be handled okay, handled by HMaster. Okay, see where to store data, how to read the data, everything will be controlled by HMaster. Without H master, nothing will work, okay, in HBase. Understood? Or any questions?
Is there any HA for H master, sir?
Of course, yes, sir. You can have multiple H masters. Got it?
So here Juniper is only interact with the client and H master, right?
Yes, yes, sir. And okay, Zookeeper will take care of the H master availability also. Who should be active H master? If active H master is failed, okay, changing standby H master to active. So that one will be taken care by Zookeeper. Got it? Got it or any questions? Okay. So I've given a simple introduction about okay, what is Zookeeper, what it does, okay, H master, okay, region server, region store, okay, mem store, H file, okay, H log, all these things I have given simple explanation. Okay. So now if you go to the next slide, okay, so this is HBase auto sharding, okay.
So Hlog we need to see sometime in, means do we need to see Hlogs
HLog,
as an
okay,
admin?
you know what is HLog, sir? I told that okay, data will be stored up to okay, okay, till it reach 128 MB, correct? Data will be stored in
Yes, sir.
Okay. So now,
Yes.
okay, inside memstore, okay, we have 100 MB data. Okay. We have data in memstore means is it reached SDFS? You have data in memstore. Does it mean okay, it is reached in SDFS? No, it is still in region server memory, region memory. Okay.
Yes, sir.
So what in case suddenly somebody switched off this region server? The data will be lost, right?
Yes, sir.
Yes. Okay. So that is the reason. Okay. HLog is kind of a bin log in RDBMS, sir. Okay. So because of sudden failure of region server, even if you lost memstore data, still the same data will be available in the HLog until the transactions are committed. Okay, HLog will be maintained HLog also will maintain a copy of your data.
Got it, sir. And once the transaction gets finished, it will be erased.
Yes.
Okay, sir. Got it.
Once data is flushed to HDFS, okay, then HLog will be erased. Got it.
Sir, how delete or modification operation happens in like the way we discussed earlier, same way, sir? Like H
Yes,
files
sir.
will be delete will be deleted in compaction, and that's it.
Yeah. Sir, okay, delete, okay, also it is kind of a expired cell. Correct or not?
Yes, sir.
Okay. So if you delete a region server, automatically the same data will be deleted, okay, when next major compaction happens.
For modification, alteration of table or anything, sir?
Sir,
That time
alteration
also.
table, okay, see now you see this example, sir. Okay. Initially, okay, I have given the name as John, correct? Huh?
Yes, sir. Yes, sir.
Okay. Now I'm changing the name to John's. Correct.
Yes, sir.
When I change the name, okay, is it changing the original entry or creating extra entry?
Extra entry it is creating.
And it is creating extra entry in a different file. Okay.
Yes, sir.
Now,
Yeah.
is it modifying anything here?
No.
It is not modifying anything here. Okay, it is just creating extra entry here. Understood?
Okay, sir. So,
Got
sir,
my point, right?
in major compaction, it will load everything in memory. Then it will do operation. It will merge. It will delete whatever it want to do.
Exactly, sir. It will create like a different file.
Got it, sir. So, sir, maybe this activity we would be doing in non-business hours.
No. This is automatic process, sir. You don't need to do anything actually.
Okay, but sir, minor compaction is automatic, but major
minor is automatic. Even major also. Okay, so now okay, to see HBase configuration. Earlier, okay, admins used to do. Okay. But now you see major compaction every 7 days it will happen once.
Okay, sir, got it. Yeah.
Every week.
Okay.
Understood,
sir. Yeah, got it.
Okay, every time okay, it reaches 10 files, okay, it will perform this check compaction. Understood?
Got it, sir. Yes, yes, sir.
It is either on time based or okay, number of files based also. Got it? Data files.
Got it, sir.
Yeah. So as an admin, you don't need to do anything now in the latest versions. Okay. Okay. So this is how the data will be stored, guys. Okay. So here, okay, every table in HBase okay, will have one primary key. Without primary key, you will not have any HBase table. Very simple. Okay. Every table in HBase will have one primary key. Without primary key, there won't be any HBase table. Okay. Now, okay, your data will be divided into regions. Okay, based on this primary key. Okay. Now, if you see, this is the table. Okay. This is the email table, email ID table, or Gmail table. So if you see, all A to F Gmail IDs will be stored in this region. All G to L okay will be stored here. Or M to S okay will be stored here. And these regions will go and sit inside region servers. Understood? Okay. And okay, which region server is having which region server is holding which region, and what is the starting value of that region, what is the ending value of that region, that will information will be handled by HMaster. Clear? Clear? Are any questions? Okay. Okay. So minor compaction. Okay. So what is minor compaction? Minor compaction is the process of combining the configurable number of small H files into a large H file. Okay. So compaction means merging small files into big file. That is mandatory. Okay. But minor compaction is very important because okay, if you don't do minor compaction, what will happen? Okay, you will be having a lot of small files, okay, which may require too many reads, okay, and okay, so too many reads from disk, which will slow down your overall performance. That is the reason. Okay, so minor compaction is mandatory and it is an automatic process. Okay, and what is major compaction? So major compaction is a process of merging small H files into big H file. But okay, this major compaction will delete the excess cells. Suppose what even of excess cells, guys? Excess cells. Okay, some people will call it like expired cells. What are these?
The data in the cells, which is above the
Suppose
version.
if I say 3 versions,
Yeah.
okay. Now I inserted 4 values. That the first one is a excess version. If you say 3 versions, okay, HBase will store only latest 3 versions. Correct. What about the 4th version now? John, Johnson, and Johnson. John is the one first we inserted. Okay, what are the latest 3 values? Johnson and Johnson, Johnson, Johns. Okay, so the John is a excess cells now or expired cell now. Got it?
Is it a disadvantage, sir?
No. It's not disadvantage. Okay, so major compaction is you will delete this one, right? When okay, major compaction works, okay, it will delete the excess cells.
Yeah,
So
permanently deleted.
Permanently deleted. Okay, after major compaction only your table will be with the clean data, no excess data, no excess cells. Got it? Okay. So points to keep in mind while performing major compaction in HBase. What are the points to keep in mind? Okay. So data present per column family in one region is equivalent to 1 H file. Okay. So in each column family, okay, you will have data files. Okay. So when I say minor compaction will work on each region and each column family also. Okay. So now I have a table here. Okay, I have a region here with 4 column families. So here one is okay, 1 H file here. This is H file. Okay. So these are the after doing the compaction, minor compaction or major compaction, you have 1 H file per store. Understood? Normally you will have multiple H files. Okay. H file 1, 2, 3 here itself. Merging multiple H files into 1 H file is compaction. Okay. During this process, all the deleted files or expired cells are deleted permanently. Okay. So deleted data cannot be recovered. Okay. When you perform major compaction, okay, the deleted data expired cells cannot be recovered at any cost. Okay. So after doing major comparison, you will have only the clean data, no expired cells or no excess cells. Okay, so if you have only clean data, maybe your table size will be reduced. Okay, and okay, this may increase the performance of newly created HPL also. Okay, and it accepts a lot of IO. Okay, and possibilities for traffic congestion when you're performing in peak hours. So major compaction, minor compaction, it's always better to perform on weekends. Okay, instead of running it on peak hours. Okay, so this process must be scheduled at a minimum bandwidth of network table. Okay, so this process, okay, if you are scheduling, or if you're doing major compaction manually, so you should not use more of network bandwidth. Okay, you should schedule this activity with less network bandwidth, because so during this process there are chances that regions may be balanced from one region server to other region server. Okay, clear? Okay, so these are the few points which we need to consider while performing the major compaction. Okay, so the next concept is HBase Thrift server. Okay, what is this HBase Thrift server, guys? So now you know that. Okay, so this is your Mumbai cluster. This is your Hadoop cluster in Mumbai. This is your Hadoop cluster in Mumbai. Okay, so now and inside this one, okay, so we have and this is the edge node. Okay, these are the edge nodes. Okay, so these are the Hadoop nodes. Here, okay, we have name node, resource manager, H master. Okay, so then Zookeeper, ZKFC, seven nodes. Okay, server. Okay, these are the services what we have here. Okay, and okay, here when it comes to data node, the node manager, then what else? Impala daemon. If they are there, it is a server. Okay, so these are the what we have. Okay, and okay. So now, okay, so here we have what we have installed. Okay, here we have installed Scoop, Hive server 2, okay, HBase. Okay, so now if anybody want, okay, let's say, so Venkata is in Bangalore, okay, okay, he's swiping a card. Okay, so now what he will do, he will insert the card in this POS machine. This is, let's say, a swiping machine. So let's say we insert the card in the swiping machine. Immediately, swiping machine will connect to the cluster. Okay. So this is in Bangalore, okay, where I am swiping my card. Okay, but this has to connect to HBase, which is running in HBase cluster. Okay, so now, okay, we installed HBase here. Okay, can this swiping machine send a request to HBase directly? HBase is a web component here. No. Okay, so for this, okay, we have something called HBase Thrift. Okay, if anybody want reports, okay, so let's say generate reports. Okay, if anybody want to generate, or if Venkata want to generate a report, okay, he will select last 1 month transaction, that will come and hit Hive server to here. Okay, so if Venkata is swiping the card, okay, so what will happen? That will come and hit HBase Thrift. Understood? Okay, HBase Thrift is a client-facing tool or customer-facing tool now. Okay, so whenever you are swiping a card, okay, so okay, you will insert this, right? Okay, so normally you are swiping a card. Okay, so you'll insert the card here. Okay, the card will have what it will have. The card will have actually. Inside this chip, okay, you have card number, okay, expiry date, then CVV details. Okay. Apart from this, okay, so suppose if somebody is using this card, okay, the URL, okay, the URL means okay, this URL. Okay, that is the reason okay, when you insert the card immediately, so the swiping machine will connect to this URL and request okay, this HBase script server. Hey, I want details of this card. Card number is this one. Can you please help me? Okay, now HBase script has received the request okay for card number some 1, 2, 3, 4. Okay, now HBase script will pass this request to HMaster. Understood? Will pass this request to HMaster. Now what HMaster will do? HMaster will tell, okay, so you are looking for this card number, right? Okay, this card number is available here. Okay, let's say this is the place, okay, where your card number is. Okay, so now HBase script will tell, okay, so this is the place where your card number is available. Now HBase script okay, will go and read the data from here, okay, and send that result back to swiping machine. Understood this? So this is how okay, you will be okay. External users will be able to connect to HBase, which is running in our cluster. What in case if HBase script is down? Will your swiping work? Huh?
No, sir.
So if HBase script is down, okay, so swiping machine will be trying to connect to this URL. If this URL is down, okay, then gone case. Okay, that is the reason in real time okay, they will go with the multiple HBase script servers case. Do you think okay there will be only one Hive script server? No. Okay, like how you have multiple Hive servers running like in a load balancer in the same way. So they will run multiple HBase script servers again running in like a load balancer mode. Okay, whichever is so in our environment okay, we have 8 HBase script servers. We have 8 HBase script servers. Okay, so anyone can help actually. If a request comes, okay, any HBase script server will handle. Got it? The request will come and hit okay, load balancer. Under load balancer, okay, with load balancer will check okay which HBase script service is free now, and okay, it will forward the request to that HBase script, and that HBase script will extract your details and send it back to swiping machine. Then only swiping machine will understand okay, your card is valid. But if this URL says that okay, this is invalid card, okay, then swiping machine also will say that okay, this is invalid card. Understood? Are any questions? Huh?
So in Hive also we are using Thrift server. They are also same purpose.
Huh? Yeah, they are also same purpose, sir. Okay, but okay, Hive external users will connect to Hive and okay, submit a request. Normally, Hive will generate okay, will not fetch single record. Okay, Hive will generate okay, last 1 month statement, a last 6 month statement. Okay, if you want. Okay, such request will go to Hive server tools. But okay, finding one record out of millions of records, that request will go to HBase script. Got it? Okay, so
Yes.
HBase script is down. Okay, it's a kind of a problem actually. Okay, so if any internet web application, okay, that web application can be anything actually. It can be a swiping machine, or it can be ATM, it can be a gateway, payment gateway, where you provide your card number, okay, expiry date, CVV number, and okay, name. Okay, so all these are web applications. If anybody, any web applications want to connect to HBase, okay, they should have HBase script server. Okay, and if you want to start HBase script server, okay, HBase script server is not coming like a service in HBase. Okay, so where is HBase script server? Okay, so this is how you need to connect actually. Okay, this is how you can connect it actually. HBase treatment start thrift. Okay, so 1919. Okay, so this is how you will be connected to HBase thrift. You'll be starting the HBase thrift on whatever machines you want. Okay, clear? Are any questions? Okay, so the next step we will see integration with HBase. Okay, so okay, now nowadays we have tools. Okay, we have enough tools to load the data. Okay, in case of HBase, okay, let's say if I want to install, okay, or if I want to insert, okay, a data, this much data, guys. How many put commands do I need to execute? Okay. How many put statement I need to execute, okay, if I want to insert this data? 31 put statements I need to execute. Correct? One put statement needs to be executed to insert about data. Okay, but can I insert this data with one statement? Can I insert this data with one statement? Is one line. So this is altogether how much data this will be. This can be like from 20 KB data. Okay, to insert 20 KB data, you are executing. Okay, it is not even 20 KB. Okay, I would say this is some 5 KB data. To insert 5 KB data, okay, we are executing 31 put statements. Don't you think it is a tedious job? Okay, tedious job. What is tedious job here? Okay, inserting data into HBase. Is it a tedious job or not? Is it a difficult job or not? It is very difficult job. Initially, when they introduced HBase, okay, so they asked all people to insert the data in the form of put statements only. Okay, but later, okay, they felt okay executing. Okay, so tomorrow, what in case if I have 1 TB data to insert? 1 TB data I want to insert into a table. Okay, I may have to run some 100 million, no, 500 million put statements. Okay. To insert 1 TB data, I may have to run 500 million put statements. Is it possible for any developer to run those many put statements? Huh? Tell me, guys, is it possible?
No.
It is very difficult job. Okay, that is the reason what they have done. They started integrating HBase with Hive. What is HBase with Hive, guys? Okay, we'll see. Okay, what is this HBase with Hive? Okay, so normally, okay, let's see. Okay, what is the problem statement here? Problem statement with HBase. Inserting bulk data into HBase table is very risky and consuming process. Okay, it takes a lot of time, and and there is no guarantee that data is getting inserted properly. Okay, and what is the second problem with HBase? Running SQL like queries. Okay, suppose if I have HBase here, okay, if I have HBase here, Alan. So one side I opened Hive prompt, okay, other side I opened HBase. Okay, so list, when I say list, it will show you all the tables. Okay, now if I want to see the data inside college student table, what is the command I need to execute? Scan. So this is the command I need to execute. When I execute this command, this will show me the data. Correct or not? Okay, but okay, scan. Okay, scan, okay, this table, okay, this is like, okay, HBase command, okay. But okay, if I want to see the table data in Hive, what is the command I will use? What is the command I will use, okay, to see the data in HBase, in Hive? Suppose, okay, let us go here.
Let's start from table.
Yeah, so let's start from table. Okay, so like this, okay. So let's start from student. Let's say, take this one. Okay, I got the data. Okay, so Hive will support SQL like commands. Okay, but we are all okay, are super duper friendly with SQL commands. Okay, but if I ask, okay, HBase, okay, to run SQL like command, will it run? If I say select start from, what is it saying? Unexpected string. Yes or no? Okay, so because, okay, so it doesn't understand, HBase doesn't understand, okay, SQL like commands. Okay, it's a big problem with HBase. Okay, we cannot run SQL like command. Okay, let's say I have two HBase tables. Can I join two HBase tables, guys? Do we have joins in HBase?
No, sir.
No. Okay, so it means, okay, we cannot perform any kind of SQL like operations on HBase. That is the second problem. Okay, so it is, okay, join two tables is not possible. Okay, joining two tables, okay, two HBase tables. It's not possible. Okay, so here, okay, to avoid this one, okay, initially they came up with HBase integration with this is the first option, HBase Hive integration. Okay, so first solution, initial solution. Okay, this is the latest solution. Okay, let's see. Okay, what is the initial solution? Okay, HBase and Hive integration. When we integrate HBase and Hive, how it works? Okay, normally when I have a table, okay, what kind of operations we perform, guys, on table? What kind of operation you perform?
Select operation.
Load data. You will load the data. Okay, so now loading the data is easy in Hive. Okay, because even it is 1 TB data also, with one line load data into table. Okay, so with one line, so if you have okay, even if you have 1 TB data, you can load, okay, that 1 TB data with one single line. Yes or no? So okay, you remember, okay, so we loaded some data into this table. Okay, this raw table. Okay, so how many records we loaded here? Records we loaded 4,003 records. Okay, but did I execute, okay, 4,000 separate commands, or only with one command I inserted data? Okay, what I did, okay, I put all these 4,003 records into, okay, I'll open, okay, even this one also. I practice. Okay, so here using this command, okay, load data. This is the data file, okay, I have part.m file which has, okay, 4,003 records. Okay, now using one command, load data in path. Okay, load data in path. This using this one command, I inserted all 4,003 rows. Okay, all 4,003 rows. Okay, in one statement. It means, okay, even though I have 4,000 rows, 40,000 rows, 4 lakh rows, 4 crore rows, okay, I'll put all those rows in one file, and okay, I will pass that file. I will load that file using one line. Correct or not? So loading data is easy in Hive. Okay. So loading data in HBase. What is loading data in HBase? Okay. So where is HBase? Okay. If I want to load the data in HBase, okay, this is what the commands I need to execute. Okay. Put, okay, John, put 2001, put, okay, 95, put East, put Venkat, okay, like this, okay. I need to execute, okay, for each and every cell, I need to execute the command, okay, again and again, okay. So even if I want to insert this data, okay, even if I want to insert this data, I need to execute how many commands? So 4 commands for these 4 lines, and for Venkat, I need to execute 5 commands total. Correct? So is it easy? What in case if I have 10 million rows and okay, 200 columns? So it means, okay, how many commands I need to do? 10 into 200. Okay. 10 into 200. Okay. 2000 million put statements I need to execute. Is it possible for any developer to execute so many put statements? No. Okay. So that's the reason. Okay. So HBase, it is no, I would say no. Okay. So select data. What is the select data? I want to retrieve the data. Okay. Which is easy to retrieve the data. In Hive, okay, you can run SQL-like commands. So it is easy for you to retrieve the data from Hive. Okay. But in HBase, okay, you need to run scan command. Okay. I want to run some sum of salaries. Is it possible to get sum of salaries in HBase? No. Okay. So selecting the SQL query, select the data SQL query. Okay. Okay. So SQL query is easy in Hive, but it is not easy in not possible in HBase. Join 2 tables. Is it possible in Hive? Yes, in Hive, okay, I can write join commands. Okay, I can join 2 tables, but in HBase, no join. Okay, update data. Okay, so here initially no, later yes, because okay, initially no means okay, initially there was no concept of transactional tables. Okay, now they introduced transaction table. That is the reason initially no, now yes. Okay, but updating the data, HBase is good. Okay, delete the data, delete single record. Okay. Update data means update single record. Single record. Okay. Okay. So, but deleting data, okay, single record, it is possible. Okay. It is not possible in Hive. Okay, but it is possible in HBase. But okay, initially it was not possible. Okay, but now it is possible with transactional tables. Okay. Ad hoc query, Hive is good. Okay, HBase is no. Okay. Data set operations. Okay, it means okay, fetching single record. Hive is not good, HBase is good. Okay, data summarization, Hive is good, HBase is no. Okay, so it means okay, if you see here, okay, Hive has some good okay. Using okay, so these are the common operations which you perform your table data. Okay, so Hive is good for few operations and HBase is good for few more operations. Okay, so now what I'm doing, I'm integrating these two now. Okay, so how I will integrate, okay, we'll see. Okay, so first of all, what I will do, comparison is done, right? Hive integration with, okay, so now, okay, so in HBase, okay, what I'm doing, try to understand, guys. Okay, I'm in HBase now. Okay, I'm creating a table. What is the table I'm creating? It's a list. Okay, you can say college student HBase. Yes or no? Huh? This is the table I created. Okay, data insert, any data inside this one. Okay, let's see what is there inside this one. Okay, can I just created? Okay, how many rows are there? 0 rows are there. Okay. Now I will go to Hive here. I will go to Hive. Okay. Now what I will do? Use retail Hive. Okay. Okay. If these tables are there, I'm dropping this table. Anyway, those two tables are not there. Now, okay, try to understand this. Okay. Okay. I'm creating a table here. I'm creating a table. Okay. Okay. So now create a temporary table in Hive. Okay. What is not temporary table? So okay, this one, okay, I will be using on temporary basis. Okay. So now, okay, did I create? Okay. So first I'm creating a table. Okay. This is the command, okay, which you use to create the table in Hive. Okay. Now go to Hive and create a table. Okay. What is the table? Okay, I created. Yes, temp Hive, temporary Hive table. Okay. Now if I say show tables, okay, do you have the temp Hive? Huh? Yes, I just created this table. Now what I'm doing, okay, I'm saying select start from table. Okay, do you have any data here? There is no data in here. There is no data here. Okay. So now what I will do, okay, so let us see the data first. This is the data, guys. This is the data. Okay. It will be tab separated file, guys. Okay. Student.txt. Okay. Copy this file, student.txt. Okay. Okay. So this is the place where you have student.txt. Okay. So log into. Okay. As the first step, okay, I'm preparing data. Okay, this is the data I want to insert, guys. Okay, what is the data? So now if you see, this is the data student.txt. Okay, so this is the data where I want to insert into HBase. Okay, if I want to insert this data into HBase, how many input statements I need to execute? So here, okay, I have 5 columns. Okay, and okay, 20 rows. Okay, so 20 into remove the first column. Okay, 20 into 80 input statement I need to execute to insert this data. I need okay 80 put statements to insert this data into HBase. Okay. So what I'm doing now, okay, so I created a data file. After that, log into HBase okay, as ln. Okay. Again, okay, logged into Hive as ln. Okay. Now, okay. After logging into HBase, okay, I created a table student HBase. But if I check in the data in the student HBase, I don't have any data. Okay, then I logged into HN4 and open the Hive prompt. Okay, so I deleted. Okay, if these tables are available already, I'm deleting these tables. Create a temporary direct table in Hive and insert data into it. Okay, now I created a table, student ID, student name, year, score, region. Okay, and I'm telling that okay, row format field delimited fields terminated by /t. Okay, so now if I say let's start from table. Okay, there is no data here. There is no data in this table. Okay. Now insert some data into this table. Anyway, okay, we have that, right? Okay, so where is the path? Okay, home len student.txt. Okay, so now using one statement, I'm inserting this data into. Okay. Okay, so this cannot be created here. Okay, then okay, Hive. Then okay, the next step. Okay, HDFS. Okay, HDFS icon put student.txt. To RF first underscore RF data. I'm creating a directory. Okay, I'm copying the student.txt into that path. Yes. Okay. Now data is ready in HDFS. Then okay. Now I'm loading this data in Hive. Okay. Now you see. Let's start from temporary Hive. Okay. So how many records we have here, guys? Inserted 20 records into this table in the temporary table first. Okay. So there are 20 records now. All the 20 records are available here. 20 records are available here. Okay. So now, okay. Okay. So if you want to, okay. So this one, okay. Fine now. Okay. Now this is the table. Okay. There is a table I created in. Okay. So let me put this one here. So here okay, we have HBase here. Okay. We have here and okay we have HBase here. Okay, inside HBase, you created a table which is called as student HBase. This is the table you created. Okay. Inside Hive, you created a table. What is the table you created so far? So far, you created a table which is called as Hive. This is the table you created. Okay. So now, what I'm doing, okay, so this is a table. Temporary table. Okay. Temp Hive. Okay. Now, what I'm doing now, to understand, guys. Okay. So create the linked table. What are this Hive HBase linked tables? Create a linked table here. Okay. Table in Hive. What is the linked table I'm creating in Hive, guys? Okay. I'm in Hive. Now, if I say show tables, okay, I have these many tables. Now I'm going to create one more table which is called as, okay, which is called as student Hive. Okay. Great. Okay. See how I created this table, guys. Okay. Student Hive is a table. Okay. And I have some columns here. Okay. But here, okay, I'm passing, okay, some extra points here. Stored by, okay, Hive HBase storage handler. So you know what we are telling Hive, okay? Hey Hive, okay? So this is the table I'm creating inside your space, okay? But okay, while loading data into this Hive table, into this table, you don't follow Hive way of loading data. You follow HBase way of loading data. Understood, guys? You are creating a table in Hive, and you are telling Hive, hey Hive, okay? I am creating a table inside your space, but okay, if somebody is loading data into this table, don't use Hive way of loading data. Use HBase way of loading data. Okay. And what is the properties here? Okay, when it comes to properties here, okay? When it comes to properties, it is telling that okay, so this is the column mapping. Whatever they insert in student ID, SID, it should go to key column. Okay, whatever they insert in S name, that should go to, okay, student information ST name. Okay, so what I'm trying to do here, I'm trying to create this link, guys, I1 HBase. So whatever is stored in student ID, that should be your primary key. Whatever is stored in S name, that should go to, okay, this column family, this column name. Okay, here this one, okay, score this one, region this one. Okay, so this is what, okay, you need to do. So this is what, okay, you are doing actually. Okay, so now you already created a table. And okay, so here table properties. So what is the linked table here? So there is a Hive table which is getting linked with HBase table here. Guys, okay, all this circus I'm doing because okay, I want to load data in HBase without much difficulty. That is the only reason. Okay. So now here, what next? Okay, I created a table. Now if I say let's start from student Hive. See, do you have any data here in student Hive? There is no data. In student Hive, there is no data. Okay. So now what I'm doing, okay, anyway, okay, so what I did now, okay, student Hive. This is what the table, okay, I created, okay, but this table is pointed to, okay, this Hive table. Understood? So there is a table, okay, which I created, okay, and I inserted 20 rows here. This is the temporary table which I inserted, 20 rows. Okay. Now I created a table in Hive which is pointed to HBase. Okay. Now anything I load into this table, that will go and sit inside HBase. Understand? Because this is a linked table. Okay. So now
Vice versa also true.
No.
Only okay.
So vice versa also we will see. We will see that also. Okay. now, okay, we'll see. Okay, so to load these tables, okay, I need to execute. Okay, I need to set some properties. Okay, now, okay, this is the command I'm doing. Okay, so let's see what I'm doing here. I'm inserting data into Student Hive, but from where I'm selecting the data? From STEM Hive. It means, okay, so what I'm trying to do here, I'm trying to load the data, these 20 rows into this table. I'm trying to load this data into this table. Okay. So, but okay, what I told Hive, hey guys, if we are loading any data into this table, okay, you use HBase for storage. Okay. So it means, okay, if Hive load data into this table data will be stored into this one. Okay. So here, if anything you load, okay, if you load this 20 rows here, this 20 rows will go and sit here. Okay. So what is the command I need to use? Now you see. Okay, insert into table. It is inserting the data now. Is it inserted? Let's see now. Okay. What is the command to see? Let's start from Student Hive. Okay, now do we have 20 rows here? Do we have 20 rows here or not?
Yes, sir.
Okay. So then, okay. I loaded this table, right? Okay, I loaded this table. Okay, so it means, okay, now these 20 rows are here. It is showing these 20 rows. Okay. Now do I require this table now? I already loaded my data. Do I require this table? Not required. Okay. So now drop this table. Now I'm dropping the STEM Hive. It means, okay, I don't have any more STEM Hive table. Now this is dropped after loading. Now I have only two tables. Okay. The one is in Hive, one is in HBase. Okay. But okay, when I run a command, it is showing like, okay, I have 20 records now. Okay. When I run, okay, select start from table, it is showing there are 20 records. These are the 20 records. Okay. But okay, now tell me, okay, is this data coming from Hive or HBase? Data coming from Hive or HBase? Okay, we will see. Okay, we will see. At this moment, okay, we are thinking that it is coming from Hive only, but okay, we will see inside HBase. Okay, so now, okay, what is the employee one name, guys? What is the employee student ID one? Student one. What is the name? Venkat. Correct? Okay. Now, okay, I'm going to HBase and I'm changing it to Venkata. I added. Okay, let's say Venkata. I added this one. Okay. Okay. So this is what, okay, I added. Okay. Now, where I added inside HBase. It means like inside HBase, I updated the data. Or not. Okay. Now, okay. 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 Now, okay. Where's, okay, so let's start from, okay. Now you see, what is the name? Okay, let's see. What is the name it is showing, guys, now? Huh? Tell me, guys. Tell me.
Change it to Venkata Narasimha.
Right? Correct or not?
Sir.
Input some data. Okay. So it means, okay, so now tell me, okay, updated data in HBase. It means, okay, the data is where now? The 20 rows. It's here. These 20 rows are here, not here. Okay. So that is the reason when I update it here, okay, when I update it here, when I update in HBase, it is reflecting in Hive. Okay. Even okay, when I run, let's start from this table. When I run, select start from student Hive. End of the day, Hive will read the data from this 20 rows. If you have any doubt, okay, what I will do, I will insert okay, some data in HBase. I will insert one more record, student ID 21. Okay, inside HBase, I will insert student ID 21. Okay. Now you select. So do you have 21 here? How many rows it is showing now? 21 rows. Correct or not? Huh?
Yes, sir.
Okay. So, and one more thing we need to check. Okay, so enter HBase.
Sir, what about versions? It will show only latest version.
One second. So now you check inside it. Okay, scan HBase. How much data we have? 21 rows. Correct or not? It means okay. When I insert the data there, it is getting inserted here. Am I correct or not? Am I correct or not, guys? See, I inserted. Did I insert data in HBase? No, I inserted data in Hive, but okay, it inserted data in HBase. Okay, so these are called as linked tables. Okay, so why these linked tables are helpful? Because okay, in HBase, okay, we don't have okay an option to load multiple records at a time. That is the reason. Okay, so initial days of the integrated Hive with HBase. Okay, if anybody want to load the data into HBase table, they create a linked table with they create a table in HBase and they create a linked table in Hive and they load the data into this Hive linked table. That Hive linked table will forward the data to HBase. Okay. So now tell me on top of this table. Okay. Now on top. Okay. So when I run select star from table, it is okay directly coming from HBase or okay from Hive. It's coming from HBase. That is the reason. Okay, whatever I updated there, it is showing here. I updated in HBase. It is Hive is showing the same data now. Okay, and okay, if you want to see the versions, multiple versions in Hive, it is not possible. But if you want to see multiple versions in HBase, yes, it is possible. Understood? Understood or any questions?
So Hive will show only latest version, yes, sir.
Hive will show only latest version. Okay.
Sir,
Understood.
Hive can work vice versa during linked table.
Sorry?
Hive HBase ఎలా అయితే వర్క్ అవుతుంది లింక్డ్ టేబుల్ ద్వారా అలాగే వైస్ వర్సా వర్క్ అవుతాయి సార్.
It is working right now. See, I inserted data here in Hive. It is reflecting. First 20 rows I inserted in Hive. Is it reflecting in HBase also?
Yes.
Huh? And okay, 21th record I inserted in HBase. Is it reflecting in Hive also? Huh? Yes or no?
Yes, sir. Yes.
So it means vice versa also working, right?
Yes, sir. Yes.
Okay. Now tell me, can I run okay some commands? Okay, so let's start from student Hive. Where okay score greater than 95%. See, the 4 people where they scored greater than or equal to 95%. It means okay, you can run SQL like queries here. Sir, no. On HBase tables, okay. Suppose if tomorrow somebody asked, okay, hey, I want to run SQL like queries on Hive tables. What they have to do? They have to create a linked table and they can run the queries on the linked table. So linked table will get the data from HBase and show it to you. Understood? Understood, yes.
Sir, how we can find ఎలా ఫైండ్ అవుట్ చేయాలి ఏ హెచ్బేస్ టేబుల్ కి లింక్ అయింది ఏ Hive table after creating the link.
Okay, so describe formatted. You just go to describe formatted. Okay, student Hive. Now this will tell you which table name. Okay, it is linked with which table? HBase table name. Student HBase. Okay, what are the column mapping? These are the column mappings. Got it?
Yes.
Yeah. So the link information is not maintained anywhere in HBase. Got it?
So basically, sir, files are existing in HBase.
Exactly, sir. Data is existing in HBase.
Yeah, got it.
You are using Hive as a front end now. You want to load something in HBase, okay? You want to load some 100 records, give it to Hive. I will go and load with one command. You want to read data from HBase, you give it to Hive. I will go and read data from HBase. So these two are integrated nowadays. Integration will work very easily. Got it? Okay.
So where you integrated this one by creating the?
No, there is nothing, sir. It is auto integrated. I didn't do anything separately. But if you want to do the same thing in Apache, then you have to copy a lot of libraries, Hive libraries into HBase libraries into Hive library path. Okay, it's a risky job, but okay, Hortonworks and Cloudera, they do this job automatically when you install.
So by simply adding the service?
By simply adding service and copying the libraries from one to other.
Okay.
Okay. And if you want to delete some data, just try delete data also. Okay. So delete data. Delete. In HBase, you delete it. Delete all, I guess, not delete. Okay, so delete. Okay. Now, 15th record is deleted here. Okay, now you go and check in Hive. So let's start from table. Do you have 15th record?
No.
I deleted there. Okay, it got deleted here also. Correct?
Yes.
Okay, so it means Right, sir.
So
These are the steps.
how service means if a microservice or anything, they can also interact with via Hive with this table or?
Yes, sir. Yes, sir. But I will tell you. So this is the initial process they followed actually. Okay. These are the steps to integrate Hive.
Okay.
Create a table in HBase, create a temporary table in Hive, loaded data into temporary Hive table from local file system or HDFS. Okay, created a linked table. Okay. In Hive, loaded data into linked table from table. Linked table will forward the data to HBase table. Drop out temporary Hive table. Selected data from linked Hive table. Updated data in HBase table. Select data from Hive table. This will repeat the change in HBase. Okay, so then updated. So then return. Okay. Okay. So this is what we have done, guys. Okay. Now, guys, one question. Now I have a question. Okay. So now show tables. Okay. What will happen if I delete this table? Okay. Drop table. Will you drop HBase table also?
No, sir. Because it is structure only, yes. Yeah.
It is just structure only, pointer just. Okay. The link is dropped. Okay. Now if you say scan, it's okay. You still have your data. Got it. Okay. So this is how you will link. Okay. So this is how with the help of this linked tables. Okay. Initially, HBase developer used to load bulk data into into HBase tables. So the challenge with HBase is okay, loading bulk data into HBase tables. Okay, this is the big challenge. Okay, this challenge was okay. I mean, okay, the solution for that challenge, initial solution for that challenge was integrating Hive and HBase. Okay, but now, okay, later what HBase thought, okay, hey, okay, I'm becoming a dependent service on Hive, so let's not depend on Hive. Okay, let us give our own importing tools. Okay, so there are some importing tools. Yeah. Okay. So there is something called okay. Student. Okay. What HBase has done? HBase has thought that okay, for all loading operations, okay, for all these things, okay, we are depending on Hive. Okay, let's not do that. Okay, let us give some utilities actually. So one of the utility they have given is import. Okay, bulk load utilities. Okay. So now, okay, so anyway, okay, so log into HN4 as LN. Okay. So now create a table here. Okay, so now, okay, so bulk load. I'm creating a table here. Guess what is the table I'm creating? Okay, play student 2. Okay, now if I say scan, any data here? Just now I created this table, right? Okay, there is no data. Okay. Okay. So using HBase shell, okay, I logged in. Then I'm creating a table here. Inside this shell, creating a table. Okay. So now what I will do? Okay. So copy data. Now I logged in here. Okay, now I'm just copying this data into HBase. Okay, so this is the data I have. This is the data I have. Okay, then okay, open. Okay, HBase shell. Okay, create table here. Okay, I created a table. So then okay, no data here. Okay, now this is done. This step is done. Okay. Done. Session 1. It means, okay, so okay, try to understand, guys. Okay, now I'm doing the bulk load utility. Okay, I'm executing bulk load utility. Okay, so here is happening here when I execute this bulk load utility. Okay, now you can see some application ID here. Can you see this, guys? What is this application ID? When you get this application ID, what does it mean? Huh? It loaded the data now. Okay. It loaded the data. Okay. Using comma separator file, you need to give separator like this actually. Okay. So now insert session 1. Inside. Now you see the 20 records loaded or not. Using one command, using bulk load command, I loaded this data. Okay, this is the bulk load command which I used, okay, to load the data into HBase. Understood? I loaded the data into college student 2. Okay. So here when I load this one, here college student 2 has the data. Earlier it was not having data. Got it? Okay. So now what is happening? Okay. So HBase itself is giving a utility to utility. Okay, in HBase, okay, to load the bulk data. Okay, earlier to load the data in HBase, okay, we were taking help of Hive linked tables, but now it is not the case. Okay, HBase itself is giving import TSV. Okay, some utilities, bulk load utilities. Okay, with the help of this bulk load utilities, so HBase developers will be able to load the data very easily. Okay, but still, okay. Now you see. Let us go back to this table. Okay. So now bulk utility, okay, bulk load utility in HBase, okay, will help, okay, without Hive HBase integration, okay. And again, okay, what HBase people thought, okay, hey, why I need to depend on Hive to run SQL-like queries on HBase data? That is the reason they introduced a service which is called as Phoenix Server. Okay, so we have something called, okay. So guys, okay, these are some commands, okay, some more utilities actually. Export utility, copy table like this. Okay, we have multiple utilities in HBase. They are given. Okay, but to run SQL like commands, okay, so we need another service which is called as Phoenix Query Server. So where we install this Phoenix Query Server, we installed on HN4. Okay, so log into that machine. Log into okay, now I will log into HN4 Azalin. Okay, this is the place where I already logged in. Okay, now execute this command. Okay, now you see here, guys. Okay, this will help you. Okay, Phoenix Query Server is a service which is given by HBase to run SQL-like commands on HBase. So all these days, okay, to load the data into HBase tables, okay, we were depending on Hive. Okay, to run SQL-like queries on HBase data, you are depending on Hive. To join two HBase tables, we were depending on Hive. Okay, so now HBase itself is coming up with bulk utilities option Okay, then it is coming up with Phoenix server option, okay, which will help you to execute SQL like commands. Okay, now you see. Okay. But here there are, if you see tables, if you want to see the tables, okay, these are the tables at this moment. Okay, these are the tables we have, and if you want to see the columns, okay, you can see the columns and all. Okay, so this is to see the metadata. Okay, now okay, let us create a data table here, guys. Create table test. This is the test table I created. Okay, test table. Okay, then insert into test. Okay, then select start from. Okay, now this is the table. Okay, test table. Inserted some data. Okay, Venkata Hadoop trainer. Okay, so all these commands are SQL commands only, right? But now you go to HBase table. This one list. There's a table test now. So now there's a table test. Okay. Now scan test. Are you seeing the same data? Venkata Hadoop trainer. Huh?
Yes, sir.
Yes or no? Okay. So you can drop the table actually. So drop table. So table is dropped. Okay. Now you see. Okay. Do you have table? Do you have the table? This table, no, right? Okay. Now what I will do? Okay. So here, okay, name. Okay. So description. Okay. ID. Okay. ID integer. Name description. It's created now. Okay. ID integer values 1, Venkata, trainer. Okay. So I'm inserting one more record. 2 records I inserted. Okay. Okay, let me insert one more record also. Okay. Now if I say select start from test, how many records it is showing? Record now. Okay. So now the same HBase for the same table. Okay. HBase for the same table. Okay. Now you see these tables we have test, right? We have test. Okay. Scan test. Is it the same? Okay. Oh shit. Okay, so here 1, 2, 3. This is fine. Okay. Now you scan this data, scan test. Now you see. Venkata Hadoop trainer. Venu, student. Rani, student. Okay. 1, 2, 3. Got it. Understood, guys? Okay. So it means, okay, if you want to run any SQL like statements, okay, you can execute from here. This is what, okay, this is what the option we have now. Okay, so now if you see all the problems, okay, so in the latest versions of HBase, people are not using Hive and HBase integration. Instead, they are using bulk load utilities in HBase, okay, and HBase Phoenix server and Phoenix server, okay, to run it to sort out the problems in HBase. Understood? Initially, it was Hive HBase integration. Now bulk load and Phoenix server. Clear? Or any questions? Okay.
Phoenix is a service, sir. Here.
Phoenix server is a service. Yes. Now okay, you need to select, okay, HBase Phoenix server. One is up and running. Clear? Okay, so you have seen Hive integration, and okay, we have seen, okay, we have seen Hive integration. Okay, we have Hive HBase integration. Then okay, I have shown you bulk loading. Then I have shown you Phoenix server also. Okay, so those are the concepts we have in HBase. Now, okay, we will see the performance tuning. When it comes to performance tuning, okay.
So, sir, which one is we are utilizing Hive with the Phoenix now?
No. Okay, direct Phoenix. Why Hive again?
Oh, sorry. Yes. Okay, sir. Got it. Direct Phoenix only we are using for the service to interact.
Got it.
Got it, sir. So services to interact any, let us suppose if any services are interacting by making use of Phoenix nowadays.
Exactly, sir.
Okay, sir.
Yes. Okay, because it's a service and it can accept external requests also. Okay. Okay, the next concept is HBase performance tuning. Okay, when it comes to HBase performance tuning, less number of column families per table. Okay, normally some people will give, okay, 10-15 column families actually in one table. Okay, given 10-15 column names means, okay, how many subdirectories it will create. So think that, okay, you have a table with 100 regions and 15 column families. So you will have 1,500, 100 into 15, 1,500 subdirectories created on HDFS. Okay, so tomorrow when you run a query, your query may have to execute on these many subdirectories. Okay, that is the reason, okay, what HBase is suggesting, don't go for higher number of column families. Okay, 4 or 5 are the good number of column families per table. Okay, then enable block caching. Enable block caching, it means, what is this enable block caching? Normally when you're reading data, any data from HBase, okay, so okay, HBase data will finally store into HDFS, right? Yes or no? Finally, where the HBase data will be stored? HDFS. Okay, so now the question is that, okay, so when you're reading, okay, when you're extracting data, okay, when you're running some queries, it has to read from HDFS or not? Huh?
Yes, sir.
It has to read from HDFS. Correct. Okay. So now the question is that, okay, every time you run the same query, will it read from HDFS disk? Or, okay, the recently read data will be kept in memory. HBase will keep the recently read data in memory. So that, okay, so that is called block caching. Okay, so whenever it is reading some data, HBase will maintain that data in memstore. Okay. Okay, so if people are running same queries, first time only it will read from HDFS. Second time it will give the result from memory. Okay, so that is block caching. So earlier, okay, this block cache option was disabled by default. Okay, but now they enabled this option by default. You don't need to do anything. Okay, usage of compression techniques. Okay, so normally in HBase you will be loading terabytes and petabytes of data. Okay, so in such scenarios, okay, if you enable some compression techniques, okay, it will be good. Okay, then usage of compaction scripts to remove deleted or expert cells. Okay, it is when you have a table where you're doing a lot of inserts, okay, a lot of updates and okay, deletes. Okay, it's always better to run run this compaction script, major compaction scripts, okay, very often on such tables, so that you will not have expired or unwanted data in the tables. You need to limit number of H files also. Okay, so by default, how many H files, okay, you can have in one directory. So major compaction will start, okay, by default, okay, 10. Okay, number 10. Okay, if there are 10 files, okay, automatically major compaction will start. Okay, minor compaction will start before that itself. Okay, that's not a problem, but major compaction. Okay, but okay, so if you limit these files to 5, that is very good actually. Okay, so 10 is good number. Okay, fine, but still you want to reduce size. Okay, then okay, you can go for 5. Okay, so these are some techniques, okay, where you can use it to increase the performance of your HBase. But apart from that, okay, nothing much we do on HBase part, to be frank. Say from our side, okay, if the services are stopped, okay, we start the services. Okay, and okay, majority of the things are done by developers itself in HBase. Whatever I've shown you, all these things are what to say, developer related work only. Okay, then real-time issues in HBase. What are the real-time issues you can see? HBase services are going down, okay, with out of memory exceptions. Okay, so let us take this scenario, guys. Okay, so if you see the HBase architecture, okay, whenever somebody submit a command, that will command hit HMaster only, right? Okay, what in case if so many requests are coming to HMaster? At times, okay, it may be unable to handle those many requests actually. Okay, so there are high chances that okay, your services may go down without memory exceptions, especially the thrift services. Okay, we need to continuously monitor this HBase thrift services. Okay, there are, if you have less thrift servers, okay, initially we had only 3 thrift servers, guys. Okay, daily at least okay, 1 or 2 thrift servers used to fail and okay, we used to restart. So now we added a total 8 thrift servers. Okay, so now we are not seeing failures because okay, the load can be managed with all 8 thrift servers. Okay, but you have more incoming requests and okay, less efficient thrift servers, then definitely services will go down without a memory exception. Okay, so at times okay, these thrift services may go to hung state also. Okay, due to more concurrent connection, more connections if created. If multiple people try to connect to HBase thrift, then okay, there is a chance of going to hung state. Okay, unable to
Is there
connect.
any way how to check how many users like these stats?
Like normal Linux command also you can use, right?
Okay, sir.
Yeah. So unable to connect HBase from external web applications. Okay, this is also one issue. Okay, so if you check, okay, the service will be showing like okay, yes, okay, I'm running, but okay, if external users try to connect to that, okay, it will not work. Okay, maybe hung state. Okay, service is showing green, but it is in hung state. Okay, that is one possibility. Okay, then H regions are going offline. Okay, this is the next trend. Okay, very common issue. Okay, so what is going offline? Going offline. Okay, so at times, okay, what will happen? Okay, so if some of the H region servers are down, okay, whatever the regions were handled by those failed regions, okay, will go to offline, will not be available. If H region server is down, okay, whatever regions we have available inside that HBase, I mean, okay, inside HBase region server, okay, all those things will be lost, will go to offline, not lost. Okay, all those things will go to offline. Okay, so and these offline regions will be automatically come online with the help of masters. Okay, but okay, if they are not coming online, you may have to execute some commands. So these are the commands. Okay, so these are the commands, guys. HBase table repair commands. These are the common commands you go to any company. Okay, so you will execute only these commands only. This will fix all the issues. Table repair commands. Okay, then closing and assigning. Okay, so if you want to do normally, okay, region balancing will happen automatically. Okay, but if you still want to do this region balancing operation manually, you can close the region and assign the region. You can use. Okay. Then problems during bulk load process. Okay.
Sir, assigning this thing, I didn't get.
Assign to different region servers.
Okay, okay. Manually we need to.
Manually. Yes.
Okay, sir.
So problems during bulk load process. Okay. So when you're loading data, import TSP, import CSP, when you're using these jobs, okay. So HBase will take the help of resource manager. Okay, when you're doing bulk load process. Okay. So these things can be, I mean, there are chances, okay, so chances that your jobs may fail during bulk load process. Okay, and join issues when integrated with Hive. Okay, so if you integrated this with Hive, when you are joining two tables, there may be some performance delays because Hive is not holding any data. Okay, end of the day, if you run Hive queries, okay, end of the data is coming from HBase, so there may be some performance issues. So major compaction for large tables. Normally, okay, if you are performing major compaction for large tables, okay, those tables may take some time. So until the compaction is completed, process is completed, so users cannot run any queries. Okay, so if users try to access the data during this time, they may get error saying that major compaction is in progress. Okay. So these are some real-time issues where you can see from HBase, guys. Okay. So I guess, okay, we are done with HBase. Okay, we spent enough time on HBase, and tomorrow we will see Flume, Kafka, NiFi. Okay, so these are the next tools. Here are any questions? Okay, so just go through this. Okay, I'll share today's video, guys. Okay, so please go through today's video, and okay, and if you have any questions, please ask me. Okay, we'll discuss tomorrow. Okay.
Venkat sir, in Hive, order by and sort by, there are two, order by and sort by. What is the difference in that?
I don't think we have sort by, right? We have order by only. Some SQLs will support a order by, some SQLs will support a sort by. Okay. But okay, order by only we have, sort by no.
Single reducer.
Yeah. Any other questions? Okay. Fine. Okay. If no questions, we'll stop it here, guys. Okay. So.
Sir, Sir Varghese here. I have some issues with my CDP installation. Just wanted to show you after this if a class is over.
Okay. What is time now? 9 o'clock, right? So, sir, maybe shall we connect? Okay, guys. Okay. Say from last 3 days, I didn't go to office also because of some personal reasons. I'm sure there will be some mails, okay, for me. So I need some time to read my mails. Okay. I'll post a message, okay, in group, okay, today, guys. Okay, maybe whenever I get some free time, okay, I'll definitely post. Okay, I'll not take more. Maybe okay. So 11:30 we can connect. 11:30.
Okay, sir. I'll reach out to you 11:30.
Yeah,
Sir,
please.
in
Okay.
evening it is
Tanuja, you
possible to
also.
use.
Tanuja, what is the status?
Failed, sir.
Failed again, huh?
Sir, in evening it is possible to use, sir, for doubts, at least for 10 minutes.
Sure, madam. Sure. Okay. I'll give
Yeah,
because
okay.
okay. Morning, okay. I need to read all my mails. Okay, and okay. I have a meeting at 10 o'clock actually. Okay, that's the reason. I didn't open my laptop also yesterday.
Then my RAM from 16 to 32. Can I delete the servers and reinstall the Hortonworks again with 5 nodes?
32 GB, na?
Hello.
Yeah.
Yes, sir. Can I delete this?
Delete it. Okay.
Existing
You
servers?
take okay new set of VMs. Okay, 5 VMs you will take.
Okay, sir.
Do you have 32 GB RAM?
Yes, sir. Extended from 16 to 32 now.